Hey there, teachers. This is a catch-up video in a way. I have done separate videos on each of the four parts of what I call a digital mathematics, but I'm just going to do all four in one video quickly this time as kind of an exercise for me. And it's called digital mathematics because we're using technology, we're using binary computers. I'm not promising I'm going to start teaching about quantum computing. I watched those videos. I'm not really pushing to expand this. It's kind of like there's already a lot to bite off. Like, is this a week course? Is this a year course? Is this a day course? See, that's flexible. So then I've got some links from the outline to a couple of, or at least one, actual pilot implementation on the ground of like a summer school version. And there were actually three of these now, more like two. I've sprinkled Martian math in some other prototypes that I've been doing. So what I do is I test new curriculum components with, you could say focus group audiences in different ways. And like you'll be in a college, and maybe you're in the middle school, and you'll learn some stuff from me who's in another time zone, right? So the Martian math is very much connected to, you could say, organic chemistry or Linus Pauling chemistry. Like where I'm pointing with the hand on the right, where all these balls packed together, that's super familiar to the synergetics reader, someone who studied a Bucky Fuller curriculum, but this is by Linus Pauling. Up here are polyhedra made by Russell Chu, Trevor Blake, and myself from book covers. Like these are the very stiff paperboard one would get to make a bookbinding book cover, and electrical tape and heated glue gun, very serious polyhedra that lasted a long time. Still have a few of them, and they're sized exactly what you need to do what's called the whole number volumes. And we just say it that way to make it stick as a meme. Actually, the icosahedron has phi in it, and so it's 1, 3, 4, 6, 18.51 dot 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 20. And there's the rhombic triconhedron. We could say that's the 5 or the 5 plus. So there's a long story that goes here, and that story is kind of at the core of Martian math. We just use Martian math as a rather thin wrapper or layer around what's, I'd call it a humanities native, indigenous to the humanities geometry. It grew up inside of sort of a poetic space, lots of architecture, lots of engineering, and took a while to find a home, but I think in philosophy we found one. Now, Waterman polyhedra, that's a very specific topic you may not be familiar with. I was a correspondent of his, and I take credit for helping name these to be calling them Watermans, because I don't think it's not very seemly for a person to seek fame too overtly, and it's better if someone else would name them, and I think he definitely earned them to have these polyhedra named after him. And what are they? Well, it got more elaborate with time. The definition I use is just, let's just say it's a convex hull where all of the vertices are a maximum distance or less, and of a certain distance, and they're all at the centers of IVM spheres. In other words, closest packed spheres, CCP balls, the ball packing we're always talking about, right? That ball packing, you can illuminate polyhedra inside of it. And usually I would take a nuclear sphere to be at the origin, and then I'd take a sweep out arm and touch all 12 vertices at some maximum range. But then I'm not done. I have to pick up every other vertex at every IVM ball that would maximize the convex hull with that beginning, right? It's complicated and yet simple. Algorithms all find the same answers, and you get a series of polyhedra called the Waterman. Now, I feel my time has run out for these other topics. It's just Martian math does not live in a vacuum. It's a good way to explore a mathematics that's probably unfamiliar to most of you if you're in STEM. But if you're in literature, there's a growing awareness of this being part of the heritage now. This is what Bucky Fuller left in his wake with help from a lot of people, including Dr. Arthur Loeb, the crystallographer who wrote the preface to Synergetics. Now I'll just say a few words about these others. Neolithic math, this is where we allow math to mix more with other disciplines as it has in the past. Like with music, part of, we could say, ritual, sacred geometry, all of the things that people do to memorialize important ratios in architecture. We look back and we say that's called sacred geometry, but you really are encoding important information in your structures. And I'm aware there are debates that you can go through a temple and find all these magical numbers, but there's so much wiggle room when it comes to objects that large. I mean, you can sort of force it. I'm aware of skepticism. I'm not trying to push actually any specific, reading of history. I'm just saying we're looking backwards here, and we're admitting that mathematics was not always so distilled into a pure discipline as distinct from all the others. We have to sort of allow a blending of disciplines as we go back in time. Casino math, there's a lot of Native American tradition, culture, lineage in my neck of the woods. This is the Pacific Northwest. And however controversial it is that Native peoples became invested in gambling and casinos, be that as it may, good or bad, it's still a fact. And so I like calling it casino math because it's kind of indigenous. It's Pacific Northwest, but it really just means all of probability, statistics, predicting the future, even machine learning. It's really crystal ball, seeing the future if possible. Something we'd always like to be able to do. What's going to happen? We would like informed opinions, please. We need to know. It's not just a game, okay? So casino math is important, and so is supermarket math, which is sort of like energy and commerce says it all. It's this, our problem of distributing all of our goods and services in a way that makes sense to people, that doesn't feel completely inequitable, but sometimes it does, and how do we relieve that, and so on. And this is where risks come in too. The casino math stuff, sometimes the status quo is the risky one. You got to change, you know that. So I'm not here to preach, every application of all these. I just want to give you the flavor of how futuristic Martian math is very geometrical, polyhedral. Then you've got casino for risk management, supermarket for the economy, and it's kind of like Neolithic is a blend of supermarket, economy, and casino going back, just like Martian is going forward. It's like all four components are always present at all times, right? So I'm just looking through my tabs here at all that's been going on lately. I'll talk to you again shortly.